question 20 is a really tricky question. This is one of those questions that, really wants to make you assume something. It gives you pictures that look like they have right angles in them and stuff like that. You cannot make any assumptions that are not given. We're asked to identify which figure contains a pair of similar triangles. Now remember, in order to have similar triangles, we have to have the same shape. And then a lot of times we write that they have different sizes, but they could actually be congruent and be similar. In addition to this, we have a couple theorems. We have side-side-side similarity. We have side-angle-side similarity. Let's see, we also have angle-angle, and maybe another angle similarity. So if we can say that we have 3 equal sides, 2 equal sides, and an angle between them, or 2 equal angles, we can say that figures are similar. So let's look at this one. Answer choice A. It says we are given that AB intersects CD. So that tells us that there is a point where they cross. It doesn't give it a name, but they cross right here. We're given that D and C are equal. So we have one equal angle. So that means we're either going to do side angle side or angle angle. I don't really have any information about any sides. So if I can find another set of equal angles, this is the right answer. I actually have a pair of vertical angles right here. So I know that this angle here and this angle here are equal. So I would say that AD, whatever this is, and BC, whatever this is, are similar by the angle-angle theorem. Okay, so I'm thinking it's going to be A, but I might as well go through it and at least show that the other ones are not right. Answer choice C. It says given triangle ABC, and then we cut triangle ABC with an angle bisector. In this picture, it looks like this makes right angles, but we cannot assume that those are right angles. Actually, what I'm going to do is I'm going to say, let's imagine C was all the way over here, right? C's over here, I haven't changed anything over here, and that top part is still the same when we hit right here. If you look at the triangle on the left, and you look at the triangle on the right, they don't look similar anymore. Yes, we have equal angles here, yes, we have a side here, but these two sides are no longer equal in length, so it's not correct. Again, they're trying to trick you by giving you a problem that looks like this is right, but it's not actually right. If these were right angles, the two triangles would also be congruent by the left and the right one. Given quadrilateral ABCD, so we just have any general figure. They drew a parallelogram. You're talking about any quadrilateral. So if I give you a quadrilateral that has these two angles as equal, the other angles may or may not have to be equal. Maybe I want to turn this one. Let's go like this. Yeah, it's pretty hard to draw this quadrilateral, isn't it? Yeah, this is not going to work out. If you look at your quadrilateral, you have an angle set that's equal. You have the side across from that's equal. You know, this side is equal to that one. But you really don't have any information about other sides. You don't have any information about other angles or anything like that. You can't say much of anything about just a quadrilateral. It's not equal. You're given collinear points, and you know that these two angles are equal. You do not know that this pair is vertical. They're not necessarily vertical. Actually, they're definitely not vertical. So you don't have a second angle. You know nothing about these two angles. You don't have a second angle. It's not T. This is one of those questions where actually I think all three of the pictures either look, all three of the wrong answers look congruent or similar. But the only correct answer is A, because it actually has the appropriate information given in the picture. We're looking for A.